This meeting is being recorded. The next thing you'll see is my screen that I'm about to share. Entire screen and the screen too. Okay, so I hope you all can see my screen now. Before we start, let's do a thing. Everyone, open your IntelliJ, and then under the source directory, you may have like maybe hello world. So just go ahead and right click on it and do a delete. Whatever file you have, just go and delete that. Sorry. Take that out of the window. Alright, so everyone deleted that file. After that is done, right click on source, do a new Java class, and let's name it class objects. But the way you name that is uppercase C L A S S, uppercase O. It's
Wait,
right?
do we delete hello world.class or just hello world?
And just delete the hello world file.
Like the entire project?
Not the entire project, just the file under the source directory.
There's two. For me, there's two of them.
Yeah, delete both of them. One must be .class and one must be .java.
Yeah.
Yeah, delete both of them.
Okay.
And then create another file called classObjects.java if you're not using IntelliJ. But if you're using IntelliJ, then just right click on the, I'll repeat the process again. So on the source directory, right click. At this point, your source directory should be empty. There should be nothing. And when that happens, right click on it, do a new, and then do Java class. And then let's give it a name. So everyone, let's all follow the same convention. Uppercase C, LASS class, uppercase O, objects, and then hit enter. So now you'll see that there's class objects.java file created for you by IntelliJ. If you're not using IntelliJ, then don't forget to write .java at the end of the file name. So inside the file, inside the class, everyone write public static void main string yes, and then write that, and then do a system.out.println hello objects. Right? So do that while you write it. This public here, in fact, we'll be covering that today, hopefully today, if we can get to it. But in this section that we're going to start, so finally you'll know what being public means for a function main or method main here. Similarly for public of a class. So be curious. You can ask questions if you don't understand a few things. But essentially, at this point in time, what we're doing is we're telling Java that whenever you run this program, call this main first, and then do whatever is inside these two curly brackets, which is in this case, we're asking you to print hello objects on the screen. So once you have written all that, save the file, and in the run menu, click on that, and you'll see there's something called as edit configuration. Click on that, and you would see your hello world being red in color. So just come to
Where do we click to get here?
click on run,
Run. Okay.
and then click on edit configurations, and you may see hello world being red. So don't worry about that. So this whole window is divided into two parts: the left column and the right column. Right column has something called as configuration tab. So in there, in the main class, write the same class name, class objects. In fact, it will help you. If it doesn't, then still go ahead and write class objects with uppercase C and uppercase O. And once you have done that, you will hit apply, then hit OK. Anyone who's not here yet? All right. So hit OK. And once you have done that, click on run again, and then click on run class object. I think it's first option in everyone's IntelliJ. If not, just look for run class objects. It must be somewhere in the menu. When you click on that, it'll print hello objects for you.
For some reason, I can't make a new class.
Can't a new class. Okay. Can you share your screen real quick?
Sure. How do I do that? Just,
So the very bottom of
present now?
present now, yeah.
Alright, do you see this?
Yeah.
Okay, so I'm not sure where to go exactly.
So click on project. Yeah, right there where your mouse cursor is. Okay. And all right, click on that drop down to packages. Why is it empty? How did you open this? So close your IntelliJ altogether,
Okay.
and then open it again. That is very interesting. Do you know where your project is? On your
I put the code over here because you said to get rid of it.
Oh no. Okay, never mind. So delete that IML file. That's not. Do you know where it was before?
It was in my project. It was the thing listed under the project. It was the code.
Okay. Close your IntelliJ and then delete the hello world.yml.
Delete this?
Yeah.
Okay.
So you were saying delete only the java.java file. So open your IntelliJ again. Okay, go to file, do a new project. Okay, go next. Next. And then here, give it the name class objects, uppercase C, use uppercase as a first, yeah. And objects, finish. Do this window. Yeah, so now expand the class objects arrow, source, right click on it. New class, give it the same name, class objects. Your two B's.
Sorry. Just a class.
Class, yeah. Hit enter. Okay. Now inside those brackets, write public static void main.
Oh wait, what was that?
So from here, I'll share my screen. So you can just copy that, the main
Okay.
method, right?
Okay. Thank you.
No problem. So you see your screen now, right?
Yeah.
Okay. So between your curly brackets, right, this whole thing, and then run your program, and it should print hello objects.
Mine says, when I go to run, it says, run hello world.
Did that work for you? No, right? You got an error saying it can't find hello world, right? Edward?
Yeah.
Yeah. So in that case, what you do is click on the run menu on the very top, and
Yeah.
then there is edit configuration, and under the applications, you might see hello world. Delete that, or else just click on it and change the main class, which is under configuration, to class objects.
Yeah, I changed that one to class object.
Okay. Do you want to share your screen?
Okay.
Just a minor change somewhere. For everyone else, you all are getting hello objects, right? Anyone else?
Yeah, I'm getting that.
Okay. All right. So you have from hello world, change it to class objects as well.
This one?
Yeah. No, no, not that. The one on the top, it says name.
Oh, this
Yeah.
one. Okay.
Yeah.
There.
Yeah.
All right. Thank you.
So run it. Oh, it ran.
I already ran it. It says that was on.
I'm getting some. Okay. So I'll share my screen. So I hope everyone has their environment working, right? So we'll use this to write program today. All right. So let's start with today's session. Um, so we'll start with a quick review from where we stopped last time. So we looked at some data types in Java. We looked at how widening works. If you try to convert from low, from a lower memory data type to a higher memory data type, it is automatically done by Java. It's called widening. It doesn't work for Boolean. Similar to widening is narrowing. In fact, not similar, but in contrast to widening is narrowing, but it is not automatic. The reason why it is not automatic is because here we are trying to convert a bigger data type into a smaller data type. So there's a chance of losing information. Right? In case of so Java is not sure if you really want to do it, so it won't do it automatically, and you have to typecast it explicitly. You ask Java to do it for you. It is done through typecasting. We learned about three operators in Java: arithmetic, unary, and assignment operator. The arithmetic operators are of five types. We all have seen this in math, exactly the same ones: addition, subtraction, multiplication, division, and modulo. Most of these operators, they require two operands. They can't function by themselves. Right? You have to add two things. Well, you add two things essentially, or subtract from one from another. Um, Also, we experimented with few programs, and we realized how operations between two integers result in an integer, and we saw examples wherein 2 divided by 3 would give us a result 0 rather than some fraction, because Java would convert the result into integer, and it can't have floating numbers. We looked at modulo operator. It's used to get a result of the remainder after a division is conducted, which is when you divide x by y, modulo will return the remainder rather than quotient. We looked at unary operators. There are 5 of them: positive, negative, increment, decrement, and not. Logical not operator. So unary operators require only one operand. You don't need two, just one. It works on just one, like x plus plus or x minus minus as an example. The not operator only applies to Boolean types. That's one key point to remember. We looked at assignment operators. They are used to assign values or result to a variable. So when we say x equal to 5, we are using this assignment operator to assign value 5 to x variable. Assignment operators are 6 types. The simplest one is just equal to sign. The other ones are overloaded, which is a shortcut way of writing code. We looked at plus equal to, minus equal to, multiplication, division, and modulo equal to's. We looked at a few examples where we got a chance to understand how Java gives precedence to certain operators when it tries to evaluate a statement, and how having the knowledge of that can give us a clue, the reason why our programs behave in the way it behaves. So it's a good thing to keep in mind. It's very, it makes you a smarter programmer to have attention to details. So moving on, if you all have any question on this, feel free to stop me, unmute yourself, ask questions. So today's session, we'll start with objects, which is instance of classes. When I didn't know about what object is, all this was bananas to me. I hope you all have some programming experience, so you must be familiar with some objects and classes. So we'll revisit them. So idea here is we are all objects, right? So, well, why did we need object is a question. Is because we needed object is because as human, we interact with the world as objects. We treat everything as an object. And this is a very simple example to illustrate that. We all have seen infants, recent born babies, and they're cute, but they weep all the time, don't they? So any ideas on why do they weep while little babies weep a lot? Anyone? Guesses? Well, I don't know either why do they weep all the time, but my guess is maybe they see a lot of monsters all around them. They see things that they have never seen. Of course, they're newborns, and then they don't know what that thing is. So who knows? They may see everything as monsters, little monsters. But when a baby is born, it knows nothing of the entire world. It looks around and it sees things. It sees objects and has no idea what those are. But over a period of time, the baby learns that there is one special object which feeds it. It cannot be a monster. It must be milk, right? So it starts identifying these unknowns as known things now. The baby starts learning about it, and more it learns, it realizes each of these objects around the baby are distinct. They are all not the same. It looks up the cradle and sees these pretty zoo animals hanging. So it says, "Oh, this is not a monster. It's a nice, fun toy. It entertains me." It looks at this human, this person who's not a monster because it takes care of the baby, feeds the baby, and is very close to the baby all the time. So baby decides that, oh, this is not a monster. This is my mom, right? Then it looks at this other person and says, this person takes care of me as much as my mom does, but this person is not mom. There's some difference to this person, so let me call this person as my dad. Right? And then these two little objects, they run around. They are very happy around me. Let me call them siblings. And then of course grandparents, and then uncles and aunts and other relatives. And then there's something in the house which doesn't move, but things inside of it moves. Very entertaining. Let me call this television. And then bunch of characters who show up in the television. They are not humans. They look like humans. They're not humans. They speak like humans. But let me call them cartoon because they are a little different than the humans around. The baby sees a pot and says, "Oh, that doesn't move. It's green in color. It's not human. It's not TV, cartoon, nothing. It's a object of a unique kind. Let me call it plant." And of course, sun that comes up every day. And yeah, the guy who teaches Java, right? So essentially, we all are objects. That's how we interact with the world. And this is how you, I, and we all got introduced to our world around, is to figure out what are similarities and differences between everything around us. That's how we learn about them. So essentially, we all are objects. So it makes sense to learn a programming language which lets us treat everything as object. So that's how notion of objects come in an object-oriented programming language like Java. Moving away from this theme a little, let's look at these two objects, cat and dog, right? Which are two animals, of course. What are similarities between them? Any guesses? Like, unmute yourself. Give me like few similarities. Let me see if it is up the list.
They both learn like where to go to the bathroom and whatnot.
Okay.
Like they learn what's bad and what's good. Like, oh no, I can't poop there. Or I can't poop here. Like that, I guess. Like the training mat.
Nice. Do you have a pet?
Huh? Yeah, 2 dogs.
Yeah, well, that makes sense when you have this similarity come up. Okay. Anyone else? Similarity between dog and cats?
They're both animals.
Come again?
They're both animals.
Both animals. Okay. That's very obvious. Any other similarities?
They both have fur.
Okay. Fair enough.
And they're both alive.
Both are alive. Okay.
They both have ears.
They both have ears. Okay.
They both have tails most of the time.
You guys are doing good. All right.
They both have eyes.
They both have eyes. How many?
They're both objects.
Okay.
They both breathe.
They live.
I think you guys are doing really good here. So let's see how many of you made to the list. 2 eyes, 4 legs, 1 tail, 1 mouth, 1 nose, 2 ears, 1 head, and then so on and so forth. So everyone is winner here. So we all got it right. But the question is, if they have so much of similarity, what makes a animal cat and what makes an animal dog?
The meow versus the wolf.
There's
I mean, I guess that's one way to look at it, right? Like,
well, it is, but then the question is, what makes
they're different.
a wolf? Go ahead. Sorry. What are you saying? Sorry, I think I got you short.
Oh, they have different characteristics.
So is it the difference that makes them cat or dog, or is it the similarities?
It's the differences.
It is differences. Okay. Right. So if the differences makes them cat versus dog, then what do similarities make them?
Animals.
Exactly, animals, right? So what we observe here is there's a natural tendency to to combine similarities into a common type, right? So what we do is we take cats and dogs and we look at their similarities and we combine them and say, you know, these they both have these things similar because they both are animals, right? And then whatever is the difference makes one animal a cat and one animal a dog. Is that a fair assumption?
Yeah, it's pretty fair.
Yeah. So, so this is a very interesting observation. Is we try to combine, we try to classify things around us based on what similarities they have and what differences they have, right? So, mom, like mother and father, they are human, like siblings and grandparents and uncles and aunts. Everyone is human because they have certain common traits, but the difference is what distinguishes them is the minor differences they might have, right? So now, being said so, let's look at some differences between cats and dogs. There's a fun image that I found on the internet. Of course, there are like more of them, uh, uh, which is beyond the scope. But you guys are right. The differences make distinction between cat and dog. So when we create objects, we have to be mindful of both, right? We have to be mindful of what are similarities between objects and what differences. So moving on, any questions so far? All right. If you have any questions, feel free to unmute and go ahead and ask. So the human object, right? Human body, we all are objects. So this is human anatomy at a very high level. It shows how we have different organs inside our body. It doesn't show brain, but there is brain, believe me, on top of everything. And there's veins, arteries, and everything inside of our body, right? Which makes us, keeps us alive. And then this is outside of the body. Um, we have pair of hands, set of fingers, legs, and these body parts. The point here is with these body parts, we can do so many activities, right? You can kick a ball, punch something, lift heavy weights, exercise, run, read, lift, or whatever, right? So many things we do with pair of hands, eyes, nose, and everything that is externally accessible to our body, right? When we are doing these activities, do we really think about what our stomach is doing, or what is our brain doing, what is our heart doing, how is blood flowing? We don't care about, well, we care, but we don't think about how everything inside of the body is working. We just take it for granted, and then we just use our hands, eyes, legs, whatever available outside to us to function our daily routines. So that's how remarkable objects are. They hide complexities. It's very complex to learn in internals of human body, but it is not complex to use it, is it? Right? We all may not know how brain functions, but we all think, we all read, we all memorize. So we just use brain without even worrying about how it is functioning inside, right? So that's how an object should be. It should be very easy to use without knowing how it is functioning, right? Any questions? Now moving on next. So we saw that there's a human object, which is a blueprint. Every human has same internal organs and same structures, big or small, but everything is essentially common amongst everyone. Let it be newborn, all the way to elderly people of the family or in the world. They all have common internal organ system, and overall, everyone's body functions in a similar way. So we can safely say here that internals of the human body is a blueprint, and the external appearance of it, which is as a baby or as a kid or as parents and grandparents, they are instances of the blueprint, right? So everyone has the same blueprint inside or similar blueprint inside. So when we safely say that, this can be very analogous to having a class and its object. So class is the inside of things, right? An object is something that does the real work, that interacts with the real world. And similar to humans, there are cats and dogs, right? We saw how cats and dogs are two different objects, but now here we are, and we see there are so many different types of cat. They all are cats, but they are still different. Um, Similarly, there are dogs, and they all are different, but they're all dog instances, right? So, so that's what the class is. What defines internals, and object is what is the appearance or behavior or the external entity that interacts with the world. All right. So now, once we have some idea about what class and object is, let's build something based on it, right? So methods and properties. Internals of class are called properties or fields. They define the class, right? Every one of us who are here, we all have a unique mind that defines us. So even though we all have brain, but it's unique in a certain way, um, because it has certain set of experiences. So essentially, those are properties of the class. Those are the fields that that when changed, change the behavior of the class, right? So let's say if someone has you know, if I eat something wrong and then I have a stomach upset, then that will change my behavior, right? It will make me maybe feel bad and maybe use restroom more frequent, right? So the internal properties of class define the behavior, which is the external property of the object, right? The next time when you look at class and objects, you can compare it to internal and external human body. It's an easy example, I guess. So what did we learn so far? We learned about classes create objects, right? Objects do the actual work. Class is just a template, but the real work is done by the object which it creates. So class is like a cookie cutter, and then you use a cookie cutter to cut cookies out of the dough, and those cookies are the objects that are formed from the cookie cutter, and you can create as many cookies as you want, right? So you have one class, and then you can create so many objects. You have one cat object, and you have like 100 species of varieties of cat. Classes can be seen as a factory that produces objects. So a factory only produces object of one type most of the times. As an example, a car factory will produce cars and it won't produce ketchup, right? That would be such a odd factory. So general idea here is, one class will produce only one type of object. Objects maintain their state using properties and fields. Objects provide methods to interact with them, and that's what the objects are. So fun quiz. We all wait for this. I'll pick up someone randomly from the attendance list here, and let's see if you can answer this. Question is, how many objects can you create from a class in Java? So Harris, do you want to take a
D. Because the
You're
class.
right. Once you have the class, then you can create as many objects you need. Cookie cutter example, right? Cut as many cookies you want. All right, Gavin, this is for you. What specifies the behavior of objects of a class in Java? Any guesses? Gavin? All right, it's an open question. Anyone wants to take a
C.
C
Yeah.
class? What specifies behavior of object? Why class? Why do you think it's class?
Because classes create objects, so it's gonna so you choose what to put in your class, which is gonna go in the object.
No. So class is just a template, right? So the behavior is defined by methods. Methods are the ways in which your object you can interact with the object. As an example, when we wrote the class today, we had this main function in it, right? So that's the entry point for Java to interact with your program. So methods provide a way for the external entity to use your objects. So that defines the behavior. It's like hand and leg to a complex human object, right? Next question, what specifies the data or state of an object in Java? Parashar, do you want to take a guess at it?
Is it? It's fields in that case, right?
You're right. It's the fields which store the state of object. So if you change something in the object, fields will maintain that change. All right. Good job, everyone. Moving on to the next section, creating and storing objects, right? So now we saw how class can be used to create objects. So now we'll create an object. But before we do that, let's look at this example on, um, uh, why should we use classes and objects to begin with? This simple example. Um, there's just one example of a robot trying to play soccer, and then I think a lot of you must be familiar with this Minecraft object here, which is trying to grab a ball. And if you all have programmed any of this kind of things, you'll recall that for every action you perform, you have to write a program. You say move so much of distance, right, left, go around, or whatever. So you have to tell this robot all the steps to perform before it can go and actually do the function, like maybe lift a ball in this case or kick the ball. Then you have to give each detail to the robot. So what are you doing here is we are creating procedure. We are providing steps to the object, to the robot. Let's say if instead of this robot here, it was a human, you would just say kick the ball rather than telling the human lift your leg 25 degrees and pull it back and then swing it with the momentum. I mean that's too much of detail. But when it comes to programming a robot, you have to give so much of details. So looks like making a robot work is like uh, having uh, to write a program to define each step. You just can't ask a robot to go and do the work for you. You have to exactly tell what to do. So that is procedural, or that's an algorithmic programming, which means certain steps have to be followed. So objects make it easy. It lets you create as an example, a robot object, and you can say robot.kick, and it'll just go and kick the ball. It'll know how to do that. You don't have to worry about it. So that's the ease that we get out of objects. So let's write our first Java class and create an object out of it, right? So everyone, repeat of what I'm doing. So we all have this class object, right? So select your source directory, right click on it, and create a new Java class. Let's name it first.
Sorry, I think my laptop was updating while you guys did this. So what do we do?
Okay. So you deleted. Do you still have Hello World here?
I don't even have the source thing anymore for some reason.
Do you want to share your screen?
Yeah.
Anyone else still having problem with this? Can follow what we're going to do here.
Okay. So here.
Very interesting. Untitled one. Okay, click on file. Just create a new project. Do a new project. Oh, all right. Click on next. Next again. And then name it as class objects. Objects. Just for consistency. No space. Okay. Hit finish. This window. All right. Expand the class object directory on the left column. Yeah. Right click on the source. New Java class. Class object with C uppercase and O uppercase class objects. Yes. Hit enter. All right. So now I'll share my screen and then just write hello world between the class brackets, right?
Mhm.
Okay. So you all can see my screen. So right,
Oh, what is the thing called? It's person something.
yes. So right, so right click on source, create a Java class, and name it as person, and then hit enter. And once you're there, that's it. I mean, we just created a class called person. It's just empty class. Save it and come back to class objects. After hello objects, write person, name the person Joe, is equal to new person, right? Save the program and run it. Everyone? Could you all run it? Anyone who couldn't?
It says that I'm missing a method body.
You're who's having this project? Okay.
I
Missing
mean
the
Nate.
method body. Do you want to share a screen real quick?
Wait, are
Sure.
we supposed to write anything in person.java yet? Okay.
No, just run the program. The idea here is it should run without any
Okay.
problem. So Nate, do you want to share your screen? Okay. So what does it say?
It says
Java
this.
at the end of main args.
Yeah.
Yeah, the one after that you have a semicolon. Delete that. Yeah, delete that one. Semicolon, right?
Delete it.
Yeah, that's it. Just save it.
Okay.
Run. So what is happening is in Java, semicolon is saying end of statement. So when you put that, Java comes here, looks at main, and says, "Oh, it doesn't have a body because the statement ends there because there's a semicolon."
Ah.
Right. So okay, I'll
Yeah,
share my screen now.
I think I have some
thank you.
problems too.
Okay, what problem do you have?
It says that Java cannot find symbol
Can you share it?
and then symbol class person location class.
Okay.
Yep.
Right. It says class person can't find. Expand your source. You don't have a person object, so right click on source, new, Java class, the first option, and type person, P uppercase, enter, and just save it.
There was also a space between person and the brackets, I believe.
Person and the bracket, that's fine. So in like Java and most programming languages, all the white spaces are like compiler deletes it doesn't. They can put so many of them, it still won't complain. All right. But the observation was good. These spaces, a lot of times people have preferences. So that's when coding standards come into picture, is how much space is advisable versus unnecessary, right? So anyhow, so I'll take back the screen from you. All right. So now, when we all have this running, so we're going to build upon this, right? So what we're going to do is we're going to change things between these two brackets here, curly brackets here, and we're going to put things between these two curly brackets, right? So everyone is good until here. So let's resume from where we left. So what we did is we just wrote our first Java class, right? And it's you have not realized it, but it's a great achievement. We have come this far. So what we did is we created a class called person, and then we created a Joe person, right? We could have created a human and then a Joe named human, but yeah, we chose to have person. It's a preference here. So what we did here is we created, the moment you do new and the class name with brackets, you're asking Java to create an object of that class, right? So Joe is an object while person is a class, right? So you all can create an object of your own name. You can say person, let's say Grace is equal to new person. So it will be an object named Grace of type person, right? How cool is that? You can create as many of them as you want. So we created we wrote a Java class, we created an object, but the object does nothing. It's an empty class and does nothing. So let's make it do something, right? So go ahead and add these things to the person class. So everyone open your person class and then write these things in it. Maybe I can write with you all. You all can see my screen, right? Let me see if I can.
Yeah, we can see.
Okay, let me increase the font so it makes it easy. Okay, so let's write here string first name. So remember the naming convention we had is camel casing. The variable names should be camel casing. So F is lower and name is uppercase here. String last name and an integer year of birth. Integer, why integer? Because you can't have year as a fraction, right? So it's fine to have integer month of birth. Same with this, you can't have it fractions, integer day of month, day of birth. Integer hour Once you have written all that, save your file. Second of birth, no. That's too much of detail. Well, we don't need hour of birth here, but nanosecond of birth, no, we really don't need hour either, but it's here for a reason, and just to realize something as we proceed further. But essentially, we don't need that. Everyone good so far? So now when we all have come this far, then let's try to use it, right? So go back to your class object. We have created a Joe object here, a person named Joe, and Joe's first name. Guess what Joe's first name is? What? First name is Joe. How cool is that? How about Joe's last name? Joe's last name is regular, just regular Joe, right? So when is Joe born?
Can you zoom in a little bit, please?
Oh, I thought I did somehow.
Thank you.
That's good, right? So we have a regular Joe. Joe was born in his birth is 2000. You know what 2000 is known for in the world of computers? It's known for the very famous. Anyone wants to take a guess?
Y2K?
Y2K. All right.
The
No, it was actually feared that every computer in the world will have that problem. Anyone knows what Y2K bug was?
Oh yeah, people thought that when it turned to 2000, like every computer would break.
Like how? Like some Thor's hammer will fall on every computer?
Wasn't it like their security would be gone so anybody could like get in their computer or something?
Wait, did it have to do with the fact that they didn't record 4 digits of the year? They just recorded 2. So when they went over, it would repeat.
Yeah, so that's right. So earlier the date format had year. Most of the years was like two digits of the year. So after 1999, which is 99, the date would have year become 0 instead of 2000, right? And why was that? Because someone chose the wrong data type. For the date. How important it is to pick the right data type. So Joe was born in that year. He's a programmer. He was born in 2000. His month of birth. Let's write it 34. We all know 34 is not right, but let's see if Java lets us do that. Right? No one is born. No one can be born in month 34. Bear with me. Write that down. Hour of birth is minus 100. Of course, it's Joe. Everything is possible here. We know that hour of birth cannot be negative, but let's still do it. Joe dot. Did I write? Okay. You know what I missed is I missed the day of birth. Let's keep day of birth as minus 100. Hour of birth as 13. That's a valid hour actually. And then Joe lives where does Joe live? Joe lives at the Bytes and Bots office. Is Kumar Joe? Could be. You'll never know. Right. Okay. You can put your own address if you want.
What about a Kumar here? Some sort of a gossip going on there.
We have realized that Joe lives at the Bytes and Bots address. Could be Kumar.
Okay, thank you.
So what we have done is we have assigned some values to Joe's variables, and we'll see that how these values are saved inside Joe. So let's print it out. Let's see what Joe saved so far. So let's do print line and do person name, right? His name is Joe dot first name, right? And then last name, right? Fair enough. We would expect Joe's name to be printed here. Next is system.out.println. Person date of birth. So let's print the date of birth as year of birth plus that plus Joe's month of birth plus forward slash plus Joe's day of birth, right? So that's fair. Then let's do system dot out print line. Let's print where Joe lives, right? System address Joe dot address. Right? Everyone good so far? So let's run this. Voila, we got an output. Everyone see this? No, you can, at this point in time, you can go ahead and delete the hello object. We know our program is working, it's printing something, so we have something in the output. So let's run it again. There's no hello world now. So we see a few things here. Everyone, so far so good? So we all wrote this program. What's the output? Right? So the output is that. So what's wrong with the output? Anything wrong here? Anything that you want to improve?
Well, we gotta make sure that like the years are like we gotta make sure like everything's positive for like dates, and we gotta make sure like months don't go over like 12 or something like that.
Correct. That's a good observation. Any other observation?
Yeah, Joe and regular don't have a space, which looks a little odd.
Wow, that's a good observation too. Very fine observation. Any other observation? Let's see if you can find more, right? So there you go. Joe has no space, right? So any guesses on how to go and fix it? Simple. Go back to the print statement, add a space between first name and last name, and then you'll fix it. How about if you want name to be printed as a regular Joe instead? How do you fix it? You go back to the print statement and swap the first name with last, and it'll print it as regular Joe, right? But the problem here is, if you have more than one person, you'll have to repeat this again and again for every person. That's a pain process, right? If you want to do it for your entire class strength, like maybe, I don't know, 20, 30, 40 people, that's a lot of change for just one change in how you print the name. Can month be more than 12 or less than 1? It cannot be, but here it's 34. So the way we have written our object, it just lets us do anything we feel like. It has no checks and balances. Can date be negative or 0 or more than 31? If it is February, can it be more than 29? Can it be more than 28 for leap year, right? What if you want to print date of birth as month, and date, and year format with a hyphen rather than a forward slash? So anytime there's a change, we are coming to realization that there's a lot of program that you have to go and update. It's not helpful. Also with the month, what if you want to print month in words like January, February, or something like that rather than number? So how would you do that? Just imagine writing that whole logic in your main program. It's too complex. How about if you want to print true if Joe was born after 12 p.m.? So now you know why I had hour of birth there, is because I wanted to get here is we want to find out when Joe was born. Was Joe born before noon or afternoon? It's very hard to first do now. How about if you want to print all of this for all Harry Potter characters? It's too much of work. No one is going to do that. So now we know what problem our program has. Let's see if we can fix it. Right? So the problem with code is users of person class have to know inside of the class. So when you, in your main program, you had to know that Joe has a date of birth, an year of birth, um, and all of those details that needs to be filled. What happens if you forget something? You know, it's very error prone. Let's say go back to your program, you can test it. Go back and comment out the line where you set the last name and run the program. Your program will just die. Right? So it is very error prone. The person who is using, the programmer who is using your class has to know everything inside of the class to use it. And you can forget to set few things and that will have a disastrous effect. Right? Users can abuse or hack the class and set invalid values. So as programmers, when we write program, our programs are used by other programmers, right? And when we write our program, we want to be in control of it in a way that we want to define how anyone in this world should use our program. Just imagine these hackers, they go and use a system in a way that it is not intended to be used. So what happens because of that? It creates a lot of nuisance. It does a lot of harm financially, or in any other forms. Maybe someone's health-related data may get leaked. Sensitive information get leaked. Maybe someone's grades get leaked. That's not good. So we want to be very, very careful about how we write our program. We don't want people to go and hack. We don't want people to create an object of person and have a negative date in it. That's no good. The next thing, exactly the same. Users can assign wrong values to wrong fields. So let's say if you have a float to have an account balance, you may accidentally assign maybe some wrong number to it, and you'll not notice because that's an automatic conversion Java will do for you. So there's that another problem we have is users can go and assign anything. People can go and assign address to first name, and no one is going to stop them from doing that. But that's not right. So as a Java programmer, we should be careful that no one is able to wrongly use our classes. Code becomes very complex with time, and as new features get added, it gets worse. So as an example, just to find if Joe was born before midnight, before afternoon, you have to put if and else, and if there are 20 people, you have to have 20 if and else's, which is not good. If you want to change the way date is printed, instead of number in month column, you want to put maybe in words, then that's even more work. So complexity increases. That's the problem with our code. So the summary is we wrote a class and we created an object, but we still did a very procedural way of doing things. So we had to set first name, we had to set last name, we had to set all of those fields before we can use it. So that's very procedural, right? It's not object oriented for sure. So no, it's like making a robot go and pick up a ball. So let's work on solution. Enough of problems. What is the use if there's no solution to these problems? So solution, step number 1 is constructors. Right? Let's rip our class apart and put it together again and make it better. So to do that, there's something called as constructor in every class. So everyone, let's get back to our program and to our person object. Let's add a constructor. So two spaces here to enter maybe, and constructor is public. And in here. So how to identify a constructor? Constructor has the same name as a class name, right? And then either it can have no parameters or it can have something in there, but name is same as the class name, and it doesn't have a return type. So if you go back to class objects, you'll see that main has a type, which is void in this case. Now, if you compare this, let me copy this just for the comparison's sake. So these two public is common. Okay, let's forget static for now. Difference between these two is person doesn't have anything before between public and its name, which means it doesn't return anything, while main returns nothing. It's void essentially. And then main has argument. Constructor can also have argument. So constructor looks like a method, but it is not a method because it doesn't return anything. So let's have a constructor and then just put one simple statement here: system.out.println default constructor called. Save it and run your program.
What did you write after public void main string args? Oh, okay.
Oh, yeah, we have to delete that. I just pasted it here for comparison purposes to show that constructors don't return a value. Okay. So once once you've done that, run your program, and let's look at the output.
Wait, so does the default constructor go for like every single object created with the class?
Yes.
All right, and that's also the first thing that happens because I saw that it went before like all the other stuff like person name and person DOB and stuff.
Okay. You got it right actually. That's exactly what I want to discuss. This is the output we all probably got. So how different is output from the previous run? The difference is we see default constructor call being printed first before any Joe related details are printed. Now the question is, it's an open question. Feel free, unmute and jump in. How did person constructor get called? Did we call it from anywhere else? We just wrote it. We didn't change our main program at all, right?
Well, constructors get called whenever an object's created, so I don't think we have to manually call it.
So what happened when we didn't have constructor written in our program?
When we didn't have like a specified constructor, I'm pretty sure just like used a default constructor which didn't have anything in it.
But where was the default constructor?
Well, we never wrote it.
So what did Java call when we didn't write a default constructor?
It just called our class.
All right. So you are right. So constructor is called from there. The moment we create a new object, constructor gets called. Now, how did the program work even when there was no constructor is a question. So what Java does is when you don't write a constructor, like a default constructor, then Java program automatically creates one for you. So even though when we didn't write it, Java put that inside of the class for us during compile time. So it was actually calling a constructor even when we didn't write it. But the moment we decided to write ourselves, then Java started calling the one that we wrote, right? So the point here is, no matter if you declare a default constructor or not, every time you create a new instance of an object, the constructor of that object is called every single time, right? So the question is, when Java creates constructor for us, why do we need to create a constructor ourselves? Anyone wants to take a guess? No guesses. There is a very big purpose behind why we need to create constructor ourselves. Is because as we see in the output, constructor gets called before anything else gets called from that object. It gives us a chance to initialize our object with some valid known values, right? So we can pre-populate our objects before the user starts using it. So why is that important? Because if the user forgets to put last name, the program will not crash because in the constructor we could have given some value to the last name by default, right? So that solves one problem for us. Our program won't crash if people forget things. Moving on to the next one, let's look at a second variation of constructor here. So everyone, go back to person class and let's write it together. Right? So this is our default constructor. We'll write another one. You all are following till here, right? Any doubts, any questions? Feel free to reach out and unmute and ask question. So we write another constructor, and remember the rule is constructor has the same name as a class name, right? So this should be person, right? Now just put two brackets, like just do the way you did one above, and you'll see that there's an error. The error is it's saying person is already defined. So, which is true, it's just defined up a few lines up there. But this is a different type of constructor. We are passing parameter to it. So let's do string first and string last name, right? And then we do first name is equal to first, last name is equal to last name, right? So you all did that. Once you've done that, go to the person's class object class, right? And there, now we're doing the new person. Do Joe is our first name, right? And then regular our second name. And now as we are passing the first and last name as parameter, we don't need this. Right? We don't need that. Do a save. Right? Go back to person thing, and here you can write system.out.println and call parameterized constructor called, so that we know which constructor is getting called. Is it still calling the person of constructor, or is it calling the new one that we just created? Right. So when you all have that, run the program and tell me what the output is. Anything?
Can I see the person class again really quickly?
Yes. So, did anyone run the program? What happened? Then at the top, where
I ran it. It basically just did the same thing as last time, because we just put the same name.
Did the program not run into a problem?
No, there wasn't a problem. It called the constructor we made.
Really?
Wasn't it supposed to?
Let's investigate. So everyone run the program. Now let's see what's in the program output. What is the person name like? What does it say?
It says Joe regular for me.
Yeah, same with me.
Joe regular for both of you?
Yeah. Wait, where's your say?
So you guys have the.
Oh, sorry, no. I didn't delete the thing earlier, so it says Joe null now.
Oh, mine says Joe regular. Joe regular.
So is your parameter name last name? Go back to your person.
For me or for him?
For you. For
it's not. Wait, let me look. Yeah, it's last name.
And then you do last name equal to last name,
Yeah.
and it's working for you.
Wait, well, I
No,
didn't do last name with a capital N. I just did last name all lowercase.
No. So do that with capital N.
Oh, wait.
Yeah.
Oh, it has to do with capital N.
Yeah.
Oh, okay.
Mine was
Yeah, now
N.
it's doing Jonal.
Okay.
Oh, I know why. Because like it's like the same variable.
Yeah. So, so who was saying that? So everyone gets Jonal, right?
Yep.
So that's not good. What happened here? Any guesses?
I'm still getting Joe regularly.
In your person constructor, what is the parameter name? Is it last with lowercase and n uppercase name?
Yeah.
And then in the body of it, do you say last name equal to last name?
Yeah, everything in the thing is the same.
I'm doing all the same thing you're doing as well, and mine's still saying Joe regular.
Can I?
Yeah, me too.
Yeah.
It's very bizarre. So in the person, you have the same last name, right? As the parameter name. So if you look at in the person class, there's a string last name. Is that the same name variable? Like copy that variable and then paste it as parameter to your constructor. I hope you guys are doing the same, right?
Yeah, that is the same for me.
That's very bizarre. Can I look at the screen real quick? That should not have happened.
Oh, sure.
So maybe your IntelliJ is smart enough to fix that for you automatically.
Yeah, I have a capital N. It did the parameterized constructor called, but it still kept.
Go back to go to class object. I think you didn't. You have to delete the first name and last name are following the. Yeah, you don't need that.
Delete this.
Yeah, because we are passing it as a parameter, right? So I think everyone who still got Joe regular, that's because you have that left in the main.
Okay, now I got Joe null.
Okay. So I'll resume the presentation. So everyone gets Joe null now? Anyone with Joe regular? I think the reason is because you have to go back to class object and delete, like after the object is created, we were setting values to it. So you have to go and delete it. So what did we do here? So what the problem is, we get a null, right? That's not right. So what is going on? What's going on here is our parameter name, last name, is same as our method value, like variable name. Sorry, our class variable name, which is last name. So when Java comes here, it says it's not sure. Probably what it guesses is you're taking this last name variable and you're assigning the value to itself instead of assigning it to the class last name variable, right? So how to tell Java that don't do that? Use this value that parameter has, that constructor parameter has, and then assign it to class variable instead. So we do this dot last name, right? The moment we do that, it will tell compiler or Java that take the parameter and assign it to the class rather than assigning it to itself. So now if you run the program, your output should change. Give it a run.
Oh, sorry, mine still says Joe regular. What was I supposed to delete again?
So in the class object, so after you create the new object, after that there was two more statement here earlier, which was Joe dot first name is Joe and Joe dot last name was regular. So you don't, if you don't see it, you have probably deleted it. You had your output as Joe null, right? So you.
I don't see it, but I still have Joe regular. Also, hold on. Yeah, I don't see it, but
Do you want to share a screen because I'm confused about it. I thought your program was working.
Oh, I think I see it actually now. Wait, hold on. Person Joe equals new person Joe. I think I figured it out. Well, mine says Joe regular still, but I thought, yeah, mine still says Joe regular.
Okay,
Oh,
so
never mind, never mind. Yeah, I actually see it. Thanks.
okay. All right. So what did we do? Okay, first of all, we learned that you can use this dot as one way to tell Java that use class, the class where the constructor is defined, use their variable rather than from the parameter list. Secondly, what more important thing we realized achieved here is we are taking first name and last name as a parameter to construct the Joe object. So we are forcing the user to provide the first and last name before they can create an object, right? Um, so which means now if you try to create another object, let's say it's not required to be typed, but let's look at it, Joe, and then let's say uh, order is equal to new person, and you say 0 comma 1 or 2, it won't create an object for you. It won't let you do that because it will only work when you provide it string, but you're providing integer. So what you're doing is you're safeguarding your program. No one can accidentally put wrong values anymore. They may put wrong name, that's a different story, but then they can't put any integer or whatever. Secondly, they don't have to know that Joe has an internal variable called first name and last name. They don't have to know that. They just give the first name, last name, and they expect that Joe will save it somewhere, right? So there's we're seeing some value in this. So let's move on. Okay, we did all this, and now, as I said, if you can change, you try to put numbers, it won't work. Constructors make it type safe to create new objects, right? So what happened is, there's one more, before we proceed further, one more observation. When we ran the program before this modification, in the output, we saw default constructor call being printed, but now we see parameterized constructor call, right? So that's a big difference. Is what it means is Java did not call the default constructor anymore when you created a new object. It called the parameterized constructor, right? So that's uh, uh, that's another observation you can get out from here. So now we're kind of trying to control the flow of program here, right? Instead of calling default, which was being done uncontrollably, now we have controlled at least Java to make it call parameterized constructor. It makes it type safe to save the object or create a new object. So constructor chaining, this is very interesting, right? So let's go back to our person program. Now what we see here is we have two constructors, and let's comment out the address. So go to class object and just put double forward slash in before the Joe.address, and then save your change and then run your program. You see there's a null printed for the address, right? Everyone here? So just to make sure that you all have null being as the output, let's uncomment it, save it, go to person, and remember we touched upon this is constructors are a way to initialize, like give some values to our class variables before they get created, right? So after the default constructor being default constructor called statement, let's give some valid values to our fields here. So first name, let's give it blank because we don't know what the first name is, but it cannot be null either. There has to be a first name. Last name is also blank. We don't know what last name is, but it can't be null. Year of birth, let's put a default number. Could be anything, we don't know, but it cannot be negative for sure. Month of birth is, let's say, let's give it, let's give the same as we gave to Joe when we created practice code. So let's give it 34 for now. I know it's wrong, we'll fix it. Day of birth is -100. Hour of birth is 100 hours. Address is 1000. Well, so we do that, and so everyone good so far? Go to class object and then delete everything. Just create a new person, Joe regular.
Can you go back to person really quick?
Okay.
Right, thanks.
Oh wait, sorry, never mind.
So once you have this constructor written that way, go to class object and delete all that we were writing there. Just leave it as Joe equal to new person. Save files, both of them, and then run the program. And we get an output. So everyone getting the same output?
Yeah, I'm getting that output.
Yeah, I got the same thing.
It's because we called the wrong constructor.
We called the wrong constructor.
Well, we called the one that has the two inputs, but we were supposed to call the default one.
All right, let's call the default one.
Okay.
So comment that out. And then write person Joe is equal to new person, right? Now run the program.
Yeah, it works now.
What's the name?
For the name, but everything else is there.
Well, the name just goes to the default thing, which is just
Right.
nothing.
Nothing, right? So now we have two constructors. Both are doing some work, but neither of them is doing the complete work, right? So now, can we leverage both features? Like one constructor is setting up the name, the other constructor is setting up different values. So can we use both of them while creating an object? We all know that when we create an object, Java calls one constructor only, right? But can we make it call both constructors? Because calling one doesn't serve our purpose. So let me revert back to the parameterized constructor and run the program so we can analyze the output. So we see the date is 0, address is null, but in here we are actually setting some value. So it looks like, well, definitely this is not being called at all. So let's make one change and see if that solves our problem. So right here in the parameterized constructor, do write this one line, it says this, and with brackets. Do that and then run the program again.
Yeah, now it works.
Now it works here. Do you see an extra line being printed on the top? It says default constructor called. and then it says parameterized constructor called, right? So
Yeah.
if you comment out this and run it, you will see that only parameterized constructor was being called. The moment we did that, it called the default constructor first and then the parameterized constructor later on, right? So what happened is when we created the new object, Java program called this constructor here. When it came here, it called the default constructor. It went and set these default values to all our objects, variables of the objects. It came back and then it printed parameterized constructor and then assigned values of first and last name to it, right? So this is called constructor chaining, which means you can call another constructor of the class from another constructor of the same class. And how cool is that? So what we achieved here is we could assign default value to our variables and also take user input. Now we know that we can assign default values. So why not let's go and fix it. We know month of birth cannot be more than 12. Let's set it to 1 as default. Day of birth cannot be negative. Let's set it to positive number. And hour of birth, let's make it 0. Let's because the date changes at midnight, so let's keep it at 0. And we don't know what the address is, so we'll just make it empty string. Um, there it is. Everyone made that change. Now run the program. And now at least we see there's some hope. Now garbage is not getting printed. Information which is not available is blank rather than null. Right? Address is not available, but it's empty. It's not null. Null is you don't want to be in a state of null. Right? So everyone getting the same output here?
Yeah, I got.
I got that.
So now if you look at your class object, you'll see it is a little more cleaner. You don't have all that setting of variables out here. You just create an object, you print stuff. No? Have we not made? We have made programmers' experience simple here. They don't have to know what's inside Joe. Right? So we have solved some problems. Let's see if we can solve some more. Right? But before we do that, let's get back to our slides. Okay, before we understand this, let's look at our code again one more time real quick. So what we see here is there's person, right? And there's another person. Both are constructors. So they have same name. They have everything same except for one has no parameter and the other one has parameter, right? So this this idea of having method, well, constructor is not a method, but for the simplicity, having method with same names but different parameters is allowed in Java, right? So let's say I just you don't have to write it now, but just have a look. If I have a method, let's say public int add, right, and then it takes int x comma int y, it returns x plus y, which is it adds x and y and returns the value. Now, if I want to add float, will it work? It won't work because float is bigger than integer, so Java won't let you do that. So let's give it a try. If I go here and if I do joe.add and I say 3.1 or something 3.2 comma 2 point maybe 8. There's a red line. It's an error. You can't do that. You can't assign a double to an integer. Right? So what we see here is we have add, it can add only integer, right? But now, let's say you want to add double. So what you can do is public double add double x comma double y, right? And x plus y. So what we have done is we have same one method, same thing doing addition, but Java is allowing that is because it has a different signature, which means it has combination of method name and the parameter list is makes them unique. There's no other method in this class with the same name and same parameter list, right? Now let's test one thing. So now there's no error here. So let me change that to integer, and let me change that to integer here. Right? We have a big underline. Even though one returns method above returns an integer, method below returns a double, but still Java has a problem. It's not unique for Java because what Java does is it looks at only the name and the parameters for uniqueness, and it sees, oh, there are two methods with same name and parameter, so there's something wrong here. And if you look at it, it says integer like add with two integer parameters is already defined. So it doesn't look at the return type to find unique signature. It looks at the parameter and the method name, right? So what we did here is we have the same method. It does the exact same thing, which is add given numbers. But one method adds integers, the other method adds double. So what we have done is we have overridden or we have overloaded the method add, which means the operation is same, which is addition, but it takes different parameters to do that addition. So this is called overloading. One method name does multiple things. One adds integer, one adds double. Similarly, in the constructor here, same thing applies. We overloaded the constructor. One constructor takes no parameter. Other constructor takes two strings. If you try to declare a third constructor with two strings as a parameter, Java will have a problem because it will say constructor name person and two string parameters already defined. But it does let us allow, us to overload the constructors. It's very powerful. We'll realize the power of it as we proceed further in the coursework. See, it's constructor overloading is a method overloading is a feature that allows a class to have more than one method having same name if their argument lists are different. Let's look at an example. We looked at it. Integer add adds two integer, double adds two doubles. So the question is, if you call add and pass 432.44 comma 50, which of the two methods will be called? Any guesses?
The double one.
Why?
The double one because Java, it automatically widens stuff, so it's gonna see that one of them's a double, so it's just gonna make the 50 also into a double by just widening it.
So if we had another method with signature double add double x comma int y, and in that case, what method would have been called?
If it was what?
If it was add double x comma int y, so
then it would still be that one. It would call that one.
Okay. Why would that be?
Because it's a double and then an int.
Okay. Yeah, I think you're right. The reason why that is happening is because when Java looks at that, it sees one number as a double and the other number as an integer. So it goes to the class and it looks at all the add methods and sees whose signature is going to match the best. Is there any add which is double and integer parameter? There's none of them. So it will pick the next closest one, which is it cannot downgrade double to an integer, but it can upgrade integer to a double. So it finds the second method here, adds double as a parameter, like as the right method, and executes it. Similarly, we can create two constructors with different argument list. That's constructor overloading. So unknowingly, we did constructor overloading We did constructor chaining, and we saw how it works. Constructor summary. Constructors don't construct the object. Well, we thought constructors do, but actually constructors don't construct the object. Then what do they do? Java calls constructor to initialize the values of fields. So that's their purpose. Is Java gives you a chance to initialize your variables inside of a class before creating the object. So the keyword new, remember when we do a new Joe, a new person, that new creates an object, but it calls constructor so that we get a chance to assign some initial values to our objects. An object can be created by calling new followed by constructor name. Example, person Harry is new person, right? So that creates a Harry object of type person. Constructor can have 0 or more parameters. We saw that. Well, the 0 parameter constructor is called the default constructor. Parameter allow values to be passed to constructors, right? So you can pass values as parameters to constructor. We saw that. This allows to establish the initial state of the object. Constructors can be overloaded. You can have 2 constructors with same name but different parameters list. It's fine. Constructors have no return type. So when constructor runs, it doesn't return anything. So that makes it different than functions. Constructors have exactly the same name as in closing class. That's how you can identify whether a method is a constructor or not if its name matches the class name. Constructors can be private, but so remember we wrote public person constructor, both of them. You can write private, but private is not that type of constructor is not part of AP coursework, so we'll just stick with public. Constructors can be chained. We saw that from within one constructor you can call another constructor. Time check. So we have 10 minutes. So let's take a pause here. We'll resume next session from the second step in the solution so far. But before we go for today, let's run this one experiment. Remove this call from parameters constructor and put it at the bottom of it. The goal here is to understand that Java won't let you do that. This has to be, if you're constructor chaining, this has to be the first thing you do in your constructor, because at this point, well, so it has to call the default constructor first if there is chaining involved. Anyhow, so experiment with this new idea that we have learned today, and let me know if you have any questions. Kumar has an announcement to make.
All right. First, I have a question here. Do any of you need extra help similar to office hours, where we will have PK or, yeah, I think PK, that who will be available during certain hours where you can ask specific questions, any concerns for your learning. What do you think of that idea? And then also some of you, a great point today, and of course we'll share the previous lessons with you. There will be close to 10 hours of recording. After you listen to it or while you listen, then we can designate somebody to help you during certain hours. Is that a good thing? How many of you would benefit from it if we propose? I'm proposing that. Do you want that service or no? This is a question for everybody.
Wait, so the office hours are like when you just need some help on a specific topic, or?
Yeah, so far all the covered topics that Prakash has done. And if you needed any clarification, you need some extra help, because we are going to start administering quizzes and practice tests for AP. So you need to be on top of this.
Yeah, I think it's a good idea.
Okay, this is, let me see, who spoke? Zane?
Yeah, Zane.
Okay. Others?
Yeah, I think that's a good idea.
Will there be like a schedule for like the office?
We'll work with you or a time everybody will benefit from it. It's not possible to have a person at different time or different schedule. But maybe on a, it'll be either in our morning hours or in the evening, similar to this time, but on a different day, where you will be able to, you'll have access to the other mentor. Overall, there's an interest, right? Because some of you are not able to respond to this. How many of you feel that you are comfortable so far, that you have understood every topic that so far?
Me, I feel like I've gotten it so far. Makes some sense.
Okay.
Yeah, I think that like maybe later, like when it starts to get more complicated, we could have it like once every week or something.
Yeah.
Because I feel comfortable right now.
Okay. Edward?
Yeah, same with me.
Okay. Edward, how are you doing? Sorry, are you saying something? Oh, you are cutting out. So, okay. So we'll hold off on that then for now. Do email me, email mxirvine@bytesandbots.com if you have any specific questions that you want some extra help. We'll be happy to provide. And then number two, we have created a feedback / evaluation form, and it will be sending via email. Or should we share that link here? Or should we send it via email? We'll send it via email so that you make sure that you respond to the survey, the evaluation form, how the class is going. So you don't have to put your name. You can just express your feedback so that we can use that to make the program better. The goal is to make sure that you all understand, you all learn, and at the same time, you're enjoying this. Okay? So we'll send it via email tonight or tomorrow, and make sure that you look out for that email. How many of you are directly in the email, or how many of you get the communication through your parents? I know, Edward, you have an email, right?
I get it from my parents.
Yeah.
Okay. All right.
I think my email is in it, so I think I get the emails.
Yeah. I have your email. Okay. All right. We'll send. We'll use the same email ID and send that. Now let's talk about the quiz. Prakash, Fernando, what do you think? How should we do the quiz? The quiz is a Google form-based quiz, some evaluation form. Would you like to do it beginning of next class? Prakash, can you jump in? What do you think? You're the
Yeah, I think like it's not a classroom-based session as of now, so Google Forms is best way of doing it, or some kind of online portal. We can do that, and then to we can do this before the class starts. That way, if there are questions, it will be answered before we move any further. Because in my opinion, a quiz is not for anyone else but for ourselves to see how much is delta and then just improve on it. So if we feel that some questions got wrong answers and what is right, the curiosity always remains. So we can use the time before the session to kind of answer all that before we start learning anything new.
okay. So so we'll administer that in the beginning of next class then.
Yeah, we can aim for that.
Okay. All right. So make sure that you all review the content thus far. And then those of you would like to have access to the recording, I've already shared to those that gave the email ID. And if any of you would like to have access to that, let me know, because it is private. It's not in the public domain. We'll share that specifically to that email. Especially it has to be a Gmail ID. Okay, so that's all I have to say. Fernando?
No, I got nothing.
Okay. Looks like you're hungry. All right. Okay. By the way, we have somebody on this, Dimitra. Dimitra is currently interviewing for to be a mentor in programming, computer programming. So I asked her to join. So that's, if you're wondering who that is, that's Dimitra. She's from Cal State Fullerton, computer science major. So, all right. Thank you, Prakash. And I think you're doing an awesome job and sharing this amazing wealth of knowledge of 2 decades of your experience in programming and software development. I hope all of you guys are benefiting from it and making use of it. So have an amazing dinner, and we'll see you next Wednesday.
Thank you.
Thank you.
Thank you.
Thank you, everyone.
Thank you. Bye.
Thank you.
Bye.
Thank you, Dimitra. So, I'm stopping the recording.